Okay, so I'm going to walk you through the calculations for the rest of the lab. Um, the first part was to try to figure out what your specific heat value for your coffee cup calorimeter is. So I'm going to show you the next two calculations. I'm going to show you just the slight difference when you have that placed in your calculation. If you have a really bad number for the specific heat, you can run all your calculations without the coffee cup and it'll be fine. Okay. If you have a reasonable number, go ahead and calculate with it. I suspect that most of you, your coffee cup specific heat value is going to be wompy. It should be actually less than 1 is what we're looking for. So this 0.42 is closer to the value for the specific heat of the coffee cup. So if you didn't get a number close to that, then you're just going to run it the second way. But basically what we're going to do is we are calculating for the amount of enthalpy that was exchanged in this reaction. And so over here I have my data that I've collected. The cup has a mass, the mass of the water, the mass of the calcium chloride, the hot, the cold initial, the final, and then the CW. Again, we're still using Q equals MC delta T as our equation. And this group that I used are data from 13.1, but I went ahead and changed it. So whatever energy the Q cold had, that's the energy that the Q calcium had. So when you place the calcium chloride in a solution and it starts dissolving, the water is absorbing that energy, whether it's an endothermic or an exothermic reaction. And so in this set of calculations, I have the mass of the water, CW water, the delta T of the water, plus the mass of the cup, C of the cup, and delta T of the cup. All I've done is I've gone in here and I have subbed in my values, the value of the mass, the specific heat of the water, which is a set value, and then my difference between the final minus initial. Repeated with the cup's mass, specific heat of the cup, and also the delta T. Then I'm going to get a summation for my energy here. For the water, it's 6,688 joules, and for the cup, it's 158 joules. So my total enthalpy that I get for this is 6,846. Now, again, if you have not good values for the specific heat of the coffee cup, then go ahead and just run it strictly with the water. So this calculation is redone, and all I did was I focused on the water because honestly, 158 joules of energy absorbed by the cup is not going to make that much of a difference on your calculations. So the rest of the calculations are you're to determine the molar heat value of each of the tested substances. So how do you do that? Well, molar heat value basically means that I'm going to take my Q that I found earlier and I'm going to divide by the moles, which is why you have to know how much mass of the substance you have. So I'm using my values from earlier, the 6846.27. My calcium chloride mass is 40 plus 35 times 2, so 110. Now, that's for the anhydrous. If you have the hydrous value, then you'll have to add on 2 waters. So if you have hydrous, CaCl2, then yours will be 110 plus 2 times the molar mass of water, okay? Because it's a dihydrate, and so it has water attached to it. All right, once you have that, you simply take your Q divided by the moles, and this should be moles, of CaCl2. And that's what I've done here. So I took the 6846.27 divided by 0.14, and I get a fairly large number because it's measured in joules. Well, I can always change it over to kilojoules by simply dividing by 1,000. And that's how I solve for my molar heat value. So if you have no data, or maybe some of your data didn't come through, or something like this, you're welcome to use this data. Okay? for your calculations. So those are the calculations that you're supposed to do for lab. You need to do it for each one of them. So you should have your coffee cup that you've done, you have the magnesium sulfate, and you have the 3 substances that were assigned to your table. Again, if your team didn't get your 3 substances done, then you may use this data. Make sure you take time to compare the molar enthalpies of dissolution between them, because your goal is you're trying to determine the best hand warmer based on molar enthalpies and cost. And that is our calculations for this lab. Good luck, and we'll keep practicing.